Hi there, so welcome to our hydraulics flume. This is a really unique part of the kit that we've got access to in the geography team because we're linked to the civils school, or linked to the civils team. So it's based in the building that we're actually teaching, all our rooms are in, our offices. And this is a really useful bit of kit that we use at various stages of the degree to help simulate a river system or a river channel. Now obviously, and I'm sure you've all been into rivers in various parts of your A-levels, but sometimes we like to measure rivers in what we refer to as high flow situations, or in a hazard, so a flow. And obviously, it'd be great to go into rivers, we can do that, but there is a slight safety issue with regards to that, so we can't always do it. But more importantly as well, this gives us an opportunity to understand how we can maybe change a river system, what we would term a physical model, to understand how water might flow and understand the hydraulics of the system. So you can see here we've got it set up where I've got our simulated trees. So looking at how, if we were to put various vegetation within the channel, filled it up with water, to work out how it might move around the system. We've got cameras as well that we can hook onto it to understand exactly where water moves around such a structure, and then to start to think about how this could be used in an engineered or non-engineered solution to how it moves in a river system. We've also got, you can see, some AstroTurf. So what would happen if we put vegetation into a river channel, or we start to add water to it, to see how it might, if we start to add vegetation to a river, to see how it might move and how it might influence that channel itself. And then we've also got here at the end, we've got a weir plate. So again, looking at a bit more of an engineered solution rather than a more sustainable solution of a kind of a long-term solution of vegetation. What does a weir do to the actual physical processes of the river? And by looking at this on granted a much smaller scale, we're able to really start to think about some of the big hydrological questions that we have in geography, to really understand what goes on, that we can then take into the field and then start to consider what can be done elsewhere as well when we get you into the field, and how we can start to, when we go out to maybe some of the local rivers or our field trips, and start to consider what can be done or what is being done to solve some of the big questions in geography, particularly to hazards and hydrological processes. I'm going to pass you now over to Dr. Jonathan Dale, who is our lecturer in physical geography, who is a coastal scientist, and he's going to talk to you in a bit more detail about our wave tank.
Hello everybody, my name is Dr. Jonathan Dale, and I am a coastal scientist here at Coventry, and what I'm going to show you now is our wave flume. Now, there are various different things that we can do with this wave flume, and it is all controlled by this big piston that you can see behind me. So it's a pump, and it displaces the water and sends waves down the flume. And we control it all from this computer, and there's various different settings and things we can change. So we can change the wave frequency, how often there is a wave, the wave period, that's the amount of time between the waves, and we can change things like the crest height, and we can either have the same parameters, or we can have a range of different parameters happening at the same time to try and simulate the kind of waves we get in the real world. What this is also used for is not just thinking about the waves that we get sort of on a day-to-day basis out on the coast, we can also create some more extreme events. So whether that is during a storm event, or we can even look at hazards such as tsunamis, and how we can try and look at the different parameters of a tsunami wave. So after the wave is created, we can measure things like the depth. That's what these probes that you can just see hanging down here measure. And as we go along the flume, the depth actually decreases. So this is just like in the open coast, where we go from deep water and it gets shallower as we get closer towards the coastal zone. So let's jump down to the far end where we're in that shallower water and have a look at what we can do at the bottom end of the flume. So welcome to the other end of the flume, and as you can see, the flume starts to get shallower, and we can see that the bed is slowly sloping up as we go towards the end of the flume up to here. So what we use this for is trying to recreate real-world morphology and changes in coastal profile. And there's various different things we can do here. So we can create things like beaches in the centre of the flume, and we have some shingle here that is typical of what we would get on a beach in the UK. And we can look at how the waves interact with differences in beach profile and beach shape. We can also see what happens if we change things like the bed roughness, and you saw with Craig how we can change that with things like the astroturf. We can also look and see how vulnerable settlements are, and we can recreate coastal towns, coastal villages at the back end of this flume and see under certain wave conditions would they be impacted by either waves and wave activity or even things like tsunamis. And finally, the other thing we can do with these flumes is we can start to think about renewable energy sources, and particularly think about using waves as a source of energy. And we can create prototypes and design potential wave energy converters and trial them in the flume under what we can suggest are real world conditions to see if we were to build them at full scale, how much energy would they produce.